Today we're going to do the 11.2a notes, which is properties of exponents. So this is probably a review, but you know, in math, you need, just because we say it's a review doesn't mean you remember it. So what I'm just going to draw up here is something I call the Pemdas Staircase. So you guys are all pretty comfortable with PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. But with this staircase, this helps us remember the properties. So what this first property says is that if you're multiplying two terms and they have the same base, so they have to have the same base, you can keep that same base and then add the exponents. So the way the PEMDAS staircase comes into play is you were multiplying with the same base, so you step down to figure out what to do with the exponents. So you add the exponents, okay? The next rule says if you, we're going to go to it, I'm going to go down here because I like going in a certain order. Quotient. If you have the same base and you're dividing between bases, then you can keep that same base, only one of them, and subtract the exponents. So if you're dividing, you step down and subtract the exponents. Okay? The next power is power of a power. So if you have a base with a exponent and then there's another exponent, you can just multiply those together. So where you'll see that on my fancy PEMDAS staircase is if you see an exponent, you step down, or if you want to call it a power, you step down and multiply them. Okay? We know that if an exponent is negative, the way you make it positive is have it change location. So right now, this A is technically in the numerator, so it's not happy upstairs, and so if we move it downstairs, the base stays the same, but we change the exponent to positive, and we have one available apartment upstairs. It's not always that way. Anything to the 0 power is 1. We went over this, and this one and this one are very similar. If you have a power to a power, then you can distribute this. Can everyone change this real quick? Can you change that to a B for me, please? So this is going to be A to the M and A to the B. Okay? All this stuff with A can't equal to 0, that's because we can't divide by math in 0. Same thing here. And B can't equal 0 because it's in the denominator, so same thing there. Alright, so we're just going to go for it now. We don't have to spend any more time because a lot of this is review. So, here's what these powers say. Do you have the same base? Oh my gosh, yeah, we have 3. Anytime you have something that doesn't have an exponent, you're going to give it 1. The rule says you keep the base and you add the exponent. So that equals x to the 8th. Okay, so think about it. X squared is x times x. X to the first power is x, and x to the 5th is 5. So if you're ever not sure, you always have the definition of exponents, which is what I'm doing right here. Definition is repeated multiplication. Then you do that. Now, here's the tricky part. Most kids are good here, but they get to this one and they want to do 5 times 5 because you're so used to doing 5 times 5. But that's not what the rule says. The rule says if you have the same base, keep the base. It doesn't say multiply the bases together. All it says is add the exponents. So you keep the base and you add the exponents. So this is 5 to the 8th power. Okay? So leave the base alone. Next one, it starts to get a little bit more complicated and you're like, what the heck? So what we're going to do is we're going to break it down. Numbers or leading coefficients or coefficients to coefficients, numbers to numbers. -2 times 10 is -20. I always have some wonderful student who tries to put this -2 in the denominator. And I get what you're thinking. You're thinking negative exponent rule. But the -2 isn't the exponent. It actually has an exponent of 1, so you don't need to worry about that. Now, I am not doing any power of exponents here when I go, or any property of exponents. I'm just doing -2 times 10. That's -20. And then I have oh, look, I have a base of x cubed being multiplied by a base of x to the first power. So what do you do when you're multiplying bases? You add the exponents. So that's going to be x to the fourth. And then the last one, you have y to the fourth times y to the fifth. This only works because there's no addition or subtraction in here. And that's going to be y to the ninth. So I just want to show you guys something one last time. Just, I know it takes a little bit more time, but I think it's good for you to have a fallback plan. So that's what all that multiplication means. You don't see any addition or subtraction. Negative 2 times 10 is negative 20. 3 x's and another x is x to the fourth. 4 y's and another 5 y's makes y to the ninth. Okay? Now, be careful when you have negatives, but we're still going to follow the same rule. We're going to put a 1 there, and then they have the same base. Don't touch the base, okay? Leave the base. Leave the base. And then just add the exponents. So 1 plus 6 is 7, okay? All right, now we're going to use, so we just did the product of powers property, and now we're going to do the next property, the power to a power. So leave the base, and because you have parentheses or power, Pemdas says multiply the exponents. So this is 6 to the 10th power. Now, let me show you. Sorry, I said I wasn't going to do this, but I am. This means 6 squared times 6 squared times 6 squared times 6 squared times 6 squared, right? So I have 2, 4, 6, 8, 10, 6s. So if you're like, is it to the 7th or is it to the 6th? Do I add or not? Well, you can always fall back on this one if you don't like my Pemdas staircase. So this one, we are multiplying those two, so that's x to the 18th. This one, we have to be careful because this means 4 to the first power, a to the first power, b to the third power, yes? And then we're going to shower the power, okay, like this. So this shower the power only works because there's no pluses or minuses. So it's going to be 1 times 2 is 4 squared. 1 times 2, because it's power to a power, we just have more bases now. And b to the 6th. And then you do need to change this. Like, I don't expect you to know 6 to the 10th, but you definitely know 4 squared. Okay? Moving right along, this is 2 cubed times another 3, so that's 2 to the 9th, y to the 12th. And you could leave that like that, but we actually don't want you to because it's a 2. So you guys can double things really quickly in your head. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2, that's 9, is 512. You're like, I can't do it in my head that fast, but that's okay. It's not going to take you that long. All right, moving on. Express using the negative exponent and zero exponent properties. Okay, so this 4 is not got a negative exponent. So this actually looks like this. Because what's happening is you're doing 4 times 1 over z squared. And then multiplying fractions, no big problem. Top times top over bottom times bottom. Okay? So when I get to this one right here, I have a negative exponent, but that goes to both terms. So it should be 1 over 5x to the first power. Now, if you were someone who wanted to do this, so I'm going to put alternate way, because with exponents, there's different ways you can do this, and do 5 to the negative 1 over x to the negative 1, we would end up getting the same thing because you have to do 1 over 5 times 1 over x, which is 1 over 5x, which is the same thing as this guy right here. Okay? All right. B to the 0, anything I love when I see to the 0 power. Actually, I'm just going to go through these. They're all 1. Okay? So I could have a really huge set of parentheses, and then on the outside of the parentheses have it raised to the 0 power, and guess what? It's still 1. All right, so 6 is not got a negative exponent. A cubed does not have a negative exponent. It's only this guy, so the c squared goes down below. These are not like bases. None of these are, so I can't do any of the other rules. All right, negative 8 still has a positive exponent. X to the 0 is 1, so it goes bye-bye. Y cubed is unhappy upstairs, so we're going to move y cubed downstairs, and then z squared is fine, so it stays upstairs. Okay, moving on. You're going to be really careful here. 2 goes into 2 once, and 2 goes into 10 5 times. And then I have 1y in the numerator, so that's just 1. I'll leave it 1y for now. And then in the denominator, that has a positive 5, so he's completely fine and positive downstairs. However, this guy is not, so we're going to move it up. So that would be x to the 7th. And we're just going to write that in proper form. So I'm going to do x to the 7th y over 5. So when I say proper form, if you actually typed it in, I would give you that on your test because you clearly know what you're doing. This is just like proper because the x's alphabetically come before the y. Alright, let's do this one now. So I'm going to go like this and make that a positive. So that's 3 to the negative 2. And then that would be x squared. Okay. So 3 to the negative 2 is unhappy, but x squared is not. So this is going to go up, and that would be 1 times 3 squared over x squared, which is just 9 over x squared. Okay. Next guy. Oh, what the heck? Okay, this w is unhappy, so it comes downstairs. So it comes downstairs, and we have w to the 8th times w squared. What goes in the numerator is the 1. It's a placeholder. And then, look guys, we have the same base. So if we're multiplying between the same base, what do we do with the exponents? We add them. So this is 1 over w to the 10th. And then we have this guy. Again, reduce your fractions. So that's going to be negative 1 over 3. This one's going to come up, so it's going to be x cubed, because that one didn't want to move, and x to the 5th. That one's positive, so it's fine where it's at. This one's negative, we got to move it up. And then these have the same base, so we're going to, and we're multiplying between bases, so we're going to add the exponents. So this ends up equaling negative x to the 8th over 3. Okay? Alright, moving right along. Simplify using the quotient of powers and power of quotient properties. Alright, so let's go review those. If they have the same base and we're dividing, keep the base, only one of them, and subtract the exponent. Alright, so this is going to be equal to 7, 8 minus 3, which equals 7 to the 5th. So, another way to do these ones with quotients is, where do I have more 7s in the numerator and denominator? In the numerator, how many more do I have? 5. Another way, 5, 6, 7, 8, is to realize this. They're common factors. They have 3 common factors, and that's why they get to 7 to 5ths. Alright, let's take a look at this next one. We're going to break it down slowly. Okay, so I'm going to do it 2 different ways. You guys ready? So 2 is going to stay in the numerator. I see I have the x's here. Where do I have more x's, in the numerator or denominator? In the denominator. So using this, and visually do this in your head, I'm not going to write it down. This x would cancel with one of those, and I would still have 4 left over. And then if I had 12 y's lined out and 6 y's lined out, 6 of them would cancel, so it's y to the 6th. But then students always say, but when did you use this rule right here where you subtract? So I'm going to show you how to do that real quick. So this is 2x, 1 minus 5, because they have the same, and then y, 12 minus 6. Okay? So I'm subtracting the exponents. So this is 2x to the negative 4, y to the 6th. And then the negative 4 isn't happy, so 2y to the 6th over x to the 4th. Same thing. You pick your way of doing it. All right. Moving on. Here we go, 4 to the 6th over 4 to the 3. They have the same base, so I keep the base and I have more in the numerator, okay? Next one, x to the squared, x squared over x to the 7th. I'm going to have more in the denominator. And then here, this y to the negative 3 is going to move up, so that's going to be y to the 10th. And then 4 times 4 times 4 is 64. You should know that because we've done difference of cubes. Okay? So you can still use the subtraction method here. If you were to do y to the 7th minus negative 3, you need to be careful when there's negatives involved so that you get that y to the 10th in the numerator. Alright, last one, we're going to shower that power so we get a to the 6th over b to the 12th. And I know I'm multiplying because if I am power to a power, then I step down and multiply the exponent. Okay, so I would love to say that we're done because that's the front side of the notes, but we're going to spend probably about 5 minutes on the back side. You're like, well, there's nothing on the back side of my notes. I know, but you have to have these on the back side because we need to make sure we're clear, because the next lesson we have to be able to do these things properly. So here's the first problem that we're going to go over. 1/2 plus 3/2. Okay, so I'm going to write these problems and then you're going to work them and then I'm going to go over them. So I want you to like work a problem, pause the video, and go from there, because we need to make sure we know how to properly add fractions and how to multiply fractions because it comes up. So I will be checking your notes to make sure that I see this on the back side of them. Okay, so sorry. Okay, let's see. So if you think like, oh, this is so cool, like there's no letters in here, great. It shouldn't take us very long to do these problems then. They're still going. It's okay. We're gonna be quick. Especially these last ones, they look intense, but you guys are going to do fantastic with this. Okay, so here's your last problem. 1/16 to the negative 1/2. Okay, so let's start with adding fractions. When adding fractions that you see match the bottoms perfectly, guess what? Common denominators already, and then 1 plus 3 is 4. And then I can reduce that to 2. Great. Easy peasy. Next one. When adding fractions that you see match the bottoms perfectly. This one needs the times 4 so that we get 8. So I just want to be clear, tying this to last chapter. When we did LCDs, this one has 3 2's. This one only has 1. But look, when I multiply by 4, I make it have that 3. So the common denominator is 8. The numerator is 1 plus 1 times 4, which is 4, so that's 5/8. Okay, I know I'm going quickly, but you can hang. 1/4 plus 1/2 times 2 because they need to have a common denominator, and then 1 plus 1 times 2 is 2. If you cook it all, that probably didn't need to be done as a common fraction because you know 1/4 plus 1/2 is 3/4. Or bake, I should say, maybe not cook. Times 2, so that's going to be over 8, and that's 3 plus 2. Oh look, we get 5/8 again. Is it bothering anybody that I didn't box this 5/8 or this 2? Because it's bothering me. Consistency counts. Alright, we got one more adding fractions that you see. This one's times 3. So then I get 6, and I get 1 plus 3. which is 4 over 6, and those are both divisible by 2. 4 divided by 2 is 2, 6 divided by 2 is 2/3. Great. Now we're moving on to adding fractions. When adding fractions that you see, sorry, we're not adding fractions, we're multiplying fractions. Multiplying fractions, no big problem. Top times top over bottom times bottom. So you're gonna multiply the tops, multiply the bottoms, and then reduce if you can. Another way you can do it is just cancel those out. Both ways equal 3 because they have a common factor, numerator and denominator. Same thing here, these cancel, 11 and 11, so I'm left with negative 5 over 15, but those are both divisible by 5, so that's negative 1/3. So if you're like, Wilkin, why are you going so fast? It's because you guys know this stuff. I just have so much faith in you. The 7's cancel because they're common factors, so I'm left with negative 4 over 8, which is negative 1/2. Alright, moving on. So the next thing we're going to do is we're going to come up here to this guy right here, and you're like, whoa, what is that right there? Okay, so this is 1 over 8 to the 1/3. We just learned that. Yes? Okay, great. That's 8 to the 1/3. I am going to remind you right now from your previous math class that this is the power of a fraction. So when you have a fractional exponent, the numerator is the power and the denominator is the root. This is how I remember it. Where do you find people who are in power? At the top. Where do you find the roots of a tree? At the bottom. So what that means is that another way I can write this is a cube root, because the root is 3, and this is 8 to the first power, which is just 8. And then, can I get 3 of a kind out of 8? Yes, it's 2 times 2 times 2, so the cube root of 8 is just 2. So 1 over the cube root of 8 is 1/2. Okay, let's do that again. Power over root. So the 16 goes here, the power is the 4, and then, sorry, the root is the 4, and the power is the 3. So we can also put the power on the outside. So I could have also put the power on the outside up there instead of underneath. It's actually easier if you do that. So can I get 4 of a kind out of 16? Yes. That's 2 times 2 times 2 times 2. So this is not square root. This is the 4th root. So 2 to the 3rd power. So 4. So 1, 2, 3, 4, 2, 2, 2, 2. So that equals 2 cubed, which equals 8. Okay, let's try this one now. I got the 5th root of 32, and then once I do that math, I'm going to cube it. So can I get 5 of a kind out of 32? Well, 4 of a kind out of 16 was 2, then 5 out of a kind is 32, because if I added one more 2 in, that would give me 32. So this one is also 8. Coincidentally. Alright, last one says 1/16 to the negative 1/2. So that's 1 to the negative 1/2 over 16 to the negative 1/2. Okay, they're both unhappy, so they're going to switch places. 1 to any power is just 1. So if you're like, what the heck, that's just 1. And then we have 16 to the 1/2 power. So the root is 2. Yay, we love square roots. And the power is 1. What's the square root of 16? 4. Okay, so that's 4 over 1, which is just 4. You guys should know anything to the 1/2 power is a square root. Okay? Alrighty, that's it.